Good evening, Lokesh.
Good evening, sir.
Good. Okay, just let's wait for a minute. Okay. Okay, let's start. Okay, let's continue now. So we were discussing in the current electricity, isn't it? So in the current electricity, we discussed about the series and parallel combination of the cell, series and parallel combination of the resistors. Okay, na? And then we have also discussed about the Kirchhoff's law. Okay, so this is the series connection. Okay, let's discuss some examples now on this series and parallel combination of cell. Okay, right. So one method of solving the circuit is what? Using the Kirchhoff's loop law and Kirchhoff's voltage law. Okay, what is the Kirchhoff's loop law or Kirchhoff's voltage law? Summation of potential difference in a closed circuit. Closed circuit means what? If a starting point and end point are same, then what will happen? Summation of potential difference is going to be zero. And the second thing is what? That Kirchhoff's junction law. What is the junction law says? At any junction, what we will have? At any junction, the summation of current is going to be zero, or another way you can say that the incoming current must be equal to what? The outgoing current at any kind of junction. Okay, so now let's discuss the next part. Okay, let's discuss some example on that. Ajay, tell me, can we apply the Kirchhoff's law, Kirchhoff's voltage law, for the part of a circuit? Part of a circuit means what? Let's say I'm giving you a question, something like this. This is a resistor, this is a battery given, there is another resistor, another battery given, there is a resistor, battery given. Okay, right. And okay, this is how the circuit diagram is given to us. These resistors, let's take it 2 ohm, this is 4 ohm, 5 volt. Okay, this is also given 2 ohm, 4 ohm we have taken, let's take it 6 ohm, and this voltage is given as 20 volt. Okay, the current in the circuit is given to us something like this. In this branch, the current is given as 5 ampere. This branch current is given as 2 ampere. Okay. The question they are asking, this point they are calling it as the A, this point they are calling it B, and this point they are calling it as the C. Okay. So question they are asking, find VA minus VB once, find it how much it will come. And the second part, find it what is the VA minus VC will come, that also find it. Okay. Understood. This is the part of the circuit. Okay. Some more things will be there in the circuit, but only this much part of the circuit is given to us. And now they are asking us what is the potential difference between the point A and B in the circuit. Okay. So please tell me how much is that coming. First, solve few questions using the Kirchhoff's junction law and Kirchhoff's voltage law. Okay. After that, one more method is a kind of shortcut method, uh, where we will learn the nodal method to solve the questions. Okay, na? So we should know both the method to solve our questions. Okay. So please tell me how much is the VA minus VB coming to us, and what is VA minus VC is coming to us. Okay. Please tell me.
Yes, sir.
Okay. Try it and tell me what is the VA minus VB coming. And once you got VA minus VB, also find out what is VA minus VC we are getting. Okay. Let's find out both the thing. Okay. In the question, how much we are getting. Okay. How much is this coming? VA minus VB. Please tell me. See, if they are asking what is VA minus VB, what we will do, we will start with the point A. Okay. And let's say this intermediate point, this junction is D. Okay. Now tell me, at this junction, AD branch current is given, CD branch current is given. Can you tell me what will be current in the DB branch? So look at the junction D. Look at the junction, which point? Junction D. Junction means what? At least three branches should be there. Okay, then it will be called as what? A junction. Okay, so at junction D, if you look at, what are you finding? At junction D, if you look at, see that. What is the incoming current? 5 ampere. What is another incoming current? 2 ampere. So can you tell me what will be this outgoing current at the junction D? Do you see that 5 ampere coming, 2 ampere coming? So that means total 7 ampere is coming. So that means how much will be leaving the current? 7 ampere will be leaving the current. So this is how much? This is the 7 ampere. So what we applied at junction D? We applied the KCL. Okay. What we applied at junction D? We applied Kirchhoff's current law at the junction D. Once that is done, now let's write it. What is the VA-VB potential difference? Okay. So you want to find out VA minus VB. So let's start with VA. Okay. VA. Now tell me, when you go from A, there is a what coming? Is it a resistor coming? And let me write it some intermediate point, although it is not necessary, but just for your understanding. This is X. Let's call this as Y. Let's call this as the Z. Just to make you understand that what I am writing, how I am writing. Okay. So tell me, I will go from A to B. What path I will follow if I go from A to B? If I want to go from A to B, will I follow A? Then I will go A to X, then I will go X to D, then I will go Y, and then I will reach the point B. Okay, let's start writing now. What is the potential at A? Let's call it VA. Now, when I go from A to X, how are we moving? Are we moving High to low potential or low to high potential? Tell me. Which is high potential, A or X? Can you tell me which is the high potential, A or X? How do we decide high and low potential? By, if I am crossing in a circuit and I got a resistor in between, then I will look for the direction of current. Why? Because current direction is from high to low potential. So A is high potential, X is low potential. So when we go from high to low potential, I will write it minus. How much minus? I into R. Now I reach the point X. Now I will go from X to D. Can you tell me which is low and which is high? X is low potential, D is high potential. Why? Because when I'm going from X to D, I got a battery in between, isn't it? And if I look at the circuit, X is connected to negative terminal of the battery. Negative terminal matlab low potential of the battery. Okay, so X is low potential, D is high potential. So that means X is low potential, D is high potential. So I'm going from low to high. So low to high means plus. How much plus? Battery voltage. Now D to Y, again direction of current. So minus. How much minus? I into R. Y I have reached. Now Y to B. Up look at that. Y is connected to positive terminal of the battery. B is connected to negative terminal. Matlab Y is high and B is low. High to low means minus. How much minus? Battery potential. Where did I reach now? Did I reach my point B now? Please tell me. Where did I reach? I reached the point B. So after doing all these plus minus thing, where I reached? I reached the point B. That must be the potential of point B. So what are we getting? VA. Now minus 10 plus 10 gone. 7 into 4 minus 28 and minus 5 minus 33 equal to VB. So what is the VA minus VB we are getting? VA minus VB we are getting as 33 volt we are getting. Let's do the same thing for A and C. Let's start from A point. Okay. How do I reach A to C? Just in front of that I am solving so that it will be easier for you to see both the diagram. Okay. Let's say I want to reach the point C. So how I will go? I will go A to X, then I will go X to D, then I will go D to Z, then I will go Z to C. I will reach the point C. Let's start. A potential VA. A to X, current direction. Current direction matlab high to low potential. High to low potential means minus. How much minus? I into R. Next. X to D. X is negative terminal of the battery. D is positive terminal. So negative to positive terminal means low to high potential. Low to high potential means potential will increase. So plus. How much plus? Battery. Now D to Z. D to Z. See, interesting thing. Current is flowing from Z to D. Matlab Z is high potential, D is low potential. And I am going from D to Z. That means I am going from low to high potential. So plus. How much plus? I into R. Next what? Now I reach the point Z. Z is what? High potential. C is what? Low potential. High to low potential. High to low potential means minus. How much minus? Minus of battery potential. Understood? Minus of what? Minus of the battery potential. Understood? Clear? And where did I reach now? So I have reached finally the point what? C. So what I am getting? VA. Now look at that, minus 10 plus 10 gone. 2 into 6, 12. Minus 20, that is minus 8 equal to VC. So that means what I am getting? VA minus VC equal to 8 volt we are getting. Please tell me. Understood? How do we calculate the potential difference? So, whenever you are applying the Kirchhoff's voltage law, why the summation of potential drop becomes zero in a loop? Because when I am talking about a loop, my final point is same as the initial point, na? So that means if I am starting from VA, finally I will reach again VA. VA will get cancelled out. So only the sum of potential drop is there, and that is equal to zero. So that's why if it is a loop means what? If it is a starting and end point is same, then we will write only the potential differences and that summation will become zero. But if it is part of the loop or part of the circuit where starting and end point is different, then we will start with any starting point considering some potential, and then we will reach the end point at that point potential, and then that potential difference we will be able to calculate it in the question. Please tell me, clear this question? Tell me, clear this question? So let's discuss the next question. You must be seeing this as a concept, but it's not a concept. You can see simply that there are three things going to happen with a cell. Okay, right? There are three things going to happen with a cell. Either the cell is what? Charging, or the cell is what? Discharging, or what? The cell is not having any current through it. So discharging of cell, charging of cell, what is the difference in these two? See, let me just draw the circuit, okay? There is a cell, it has some EMF. This is called EMF of the cell, this is called internal resistance, okay? This point is A, this point is B. How do I call this cell is discharging or charging? What is the difference between these two? Can you tell me difference between the charging and discharging thing? Tell me, what is the difference between charging and discharging of a cell? It's a direction of current, okay? If current is coming out of the positive terminal of the cell, it will be called discharging. If current is entering through the positive terminal of the cell, it will be called charging. That is the only difference between the charging and discharging. Like this. See the direction of current? Let's say this cell is connected to some external resistance. So there will be some current in the circuit, isn't it? And the direction of current in the cell is going to be this one. So this is called discharging of the cell. Now, potential difference and EMF are two different things. Potential difference and EMF is what? Two different things. Okay. Right now, what is this E representing? E is representing the EMF of the cell. And if I ask you what is the terminal potential difference, okay, what is the terminal potential difference of a cell? That means what I am asking you? I am asking what is VA minus VV. So it is called terminal potential difference or just the potential difference across a cell. Okay. So EMF is not always equal to the potential difference of the cell or terminal potential difference of the cell. EMF will become equal to potential difference only once. Only once the potential difference will become equal to EMF, that also we will see it. Okay. Now, please tell me what is the potential difference VA minus VV? So again, the same approach I will follow. I will start with A. Now, I am going to cross. Let me call this point as something X. I am going to start from A, reaching the B, following what path? A, X, B path. So when I go from A to X, can you tell me how I am moving? High to low, na? See that A is connected to positive terminal, X is connected to negative terminal. So A is high potential, X is low potential. So A to X means high to low. High to low means minus. How much minus? E, battery EMF. Now, this is the direction of current. That means this is the direction of current in the resistor. Look at that. Current is flowing from B to X. Matlab, B is high potential, X is low potential. And I am following which path? I am following A to X to B. So that means I am going from X to B. X is low potential, B is high potential. That means I am going from low to high potential. So plus, how much plus? I into R. Where did I reach? I reached the point B. So if I calculate VA minus VB, what I am getting? E minus IR I am getting. See that potential difference across a cell, is it equal to EMF? No. What is that? It is less than EMF. Okay. So when the cell is discharging, the potential difference across the cell is going to be less than EMF of the cell. The second case is going to be charging of cell. Second one we are going to discuss is the charging of cell. What is the difference in charging and discharging? The direction of current. So this is the EMF of the cell. This is internal resistance. Okay. This terminal, let's call it A. This terminal is B. And the current in this circuit is like this. Check it. Is the current is flowing into the positive terminal of the battery? So that will be called the charging of the cell. Now again, I want to find out the same thing. What is the potential difference between A and B? So again, if I want to find the potential difference between A and B, I will go from A, I will go to X, then I will go to B. Let me start with A. So VA, A to X. Look at the terminals of the battery. A to X. A is connected to positive terminal of the battery. X is connected to negative terminal. Matlab high to low potential. A to X is what? High to low potential. High to low potential means minus EMF of the battery. Is this the direction of current in the resistor? X is high potential, B is low potential. So again minus. How much minus? IR. है ना? Potential difference across the cell is what? EMF. Potential difference across resistor is what? IR. Where did I reach? I reached the point B. So now if you write it, what is the VA minus VB? We are getting as E plus IR. Can you see that? What happened here? So in case of discharging, the potential difference is less than EMF. In case of charging, potential difference is equal to EMF. Now, the third case we have, what is that? No current. No current through what? Through the cell. If the cell is not having any current through it, now can you tell me what will be the potential difference? This is the point A, this is the point B, EMF, internal resistance. Let's call this intermediate point as something X. Again, I'm going from A to X to B. Please tell me VA minus EMF. Now, what is the current in the circuit? 0. So 0 R. Where did I reach? I reached the point B. So please tell me what I am getting VA minus VB. That is equal to EMF. So in a cell, whenever a cell is connected in a circuit, and if the circuit is complete, there are two possibilities. Either the cell will be discharging, means it will be providing the current in the circuit, it will be providing the energy to the circuit, or what else? It will be charging, means it is receiving the energy in the circuit. Okay. So both cases, what we saw, if it is discharging, potential difference we got it E minus IR. If it is charging, we got it E plus IR. But if there is no current through the cell, then only the potential difference will come how much? Equal to EMF. So please tell me, understand these things, what we have discussed? How do we write the loop law or Kirchhoff's voltage law to write down the potential at a different point in the circuit? Please tell me.
No, sir.
Yeah, please tell me. Understood or any doubt is there?
Understood, sir.
Understood, right?
That's right.
So this is what we discussed. This is how we will apply the loop law or the Kirchhoff's loop law, or you can say that voltage law. Loop law or voltage law, you can apply for a complete loop, or you can just apply partially for a loop, or partially for a circuit in the loop. Okay, partial circuit also you can apply it. Okay, understood. Series and parallel combination we have discussed, right? Okay, now up to this. Now, if we want to measure the potential difference in the circuit, or we want to measure the current in the circuit, what are the two devices we have to measure the potential difference and current? Tell me. So there are two devices we have. One is called the, okay, voltmeter, and another one is called as the ammeter. Okay, voltmeter and ammeter it is called. Okay, so what is the voltmeter? Voltmeter means what? Voltmeter, it's how we represent. This is the representation of what? The voltmeter. Okay, voltmeter is how it is made. Voltmeter is made with the help of a galvanometer. Okay, so in current sorry, magnetism part we will discuss about the working of a galvanometer, moving coil galvanometer. Okay, so voltmeter is what? Voltmeter is measure, or what it does, it measures, what it measures, it measures the potential difference in the circuit. In the circuit means what? Between any 2 points we may want to measure the potential difference, isn't it? Like we want to measure the potential difference across a resistor or the cell or the any inductor or capacitor, isn't it? So if we want to measure potential difference, है ना? If we want to measure the potential difference between any 2 points in the circuit, what we do, we use the voltmeter. Okay, so what it does, it measures, what it measures, it measures the potential difference between 2 points in the circuit. Understood? So if I want to measure the potential difference across the 2 points in the circuit, then how should I connect that in the circuit? So can I say that if I want to measure the potential difference across 2 points in the circuit, that means should I connect in parallel to that element? Let's say I want to measure the potential difference across a resistor. So what I will do, I will connect the voltmeter in parallel to that resistor. Then what will happen? We will be able to measure whatever the reading of that voltmeter, that we will say is the potential difference across the resistor. Understood? So how it is connected? So it is connected. It is connected how? Connected in parallel to the element. To the element means what? Element can be anything. It can be a resistor, it can be a battery, okay na? It can be inductor or capacitor, okay na? So it is connected in parallel to the element across which across which we want to measure the potential difference. Okay, we want to measure the potential difference. Understood? Clear? So, and one more properties of the voltmeter is what? If the question gave it's an ideal voltmeter. Ideal voltmeter means what? If a voltmeter has very high resistance, if a voltmeter has very high resistance, then it will be called very close to what? The ideal voltmeter. Okay. So whenever we connect a voltmeter in circuit to measure the potential difference, our purpose is to measure the potential difference, isn't it? So the voltmeter should have what? Such a high resistance that it should not draw any current for itself. Understood? And if I want someone to not draw any current through it, when that is going to possible? When that thing has very high resistance, isn't it? When that thing is having a very high resistance, what will happen? It won't be drawing any current through the circuit. Okay, so that's why one last point of the ideal voltmeter. For ideal voltmeter, what is the resistance? Resistance means what? For ideal voltmeter, resistance of voltmeter. Resistance of what? Resistance of voltmeter is very high, and that very high we can say that infinity, right? So for ideal voltmeter, can I say that resistance of voltmeter, how much we will consider? We will consider it as the infinity. And how a voltmeter is prepared? By modifying a galvanometer, a voltmeter is created. Okay, so to create a voltmeter, what we do? We do some modification in the galvanometer. Okay, next one is the ammeter. Okay, so ammeter, what will be the symbol of ammeter? Same thing, but we just write it what? A here. Okay, so what ammeter does? Ammeter does what? It measures the current in the circuit. Understood? What is the ammeter does? It measures the current in any circuit. What it does? It measures the current in the circuit. Okay, so what it does? It measures the current in the circuit. Understood? So if I want to measure the current in the circuit, what I should do it? How I should connect then? Then if I, let's say, I want to measure the current in any branch, okay, or current passing through any resistor or battery, what should I do it? Should I connect an ammeter in series with the circuit, in series with that resistance or voltmeter, resistance or battery? So that's why how an ammeter is connected. It is connected in series to the circuit. Okay, how it is connected? It is connected in series to the circuit. And one last thing, it is connected in series, right? Think about it. What will happen if it has very high resistance? So it will draw a very high resistance. That means it will not allow any current to flow through it, isn't it? And we won't get any measurement of the current. Okay, that's why what we do, that if I am going to use an ammeter, we will try to keep the resistance of ammeter as low as possible. Okay, so that's why for ideal ammeter, as low as possible means what? If I am going to use an ideal ammeter, what we will take? Resistance we are trying to keep as low as possible. So resistance of ammeter, can I say that is what? It is 0. Understood? So now let me draw a circuit and try to connect an ideal ammeter, an ideal voltmeter in that one. Okay, let's say this is the EMF of the cell, its internal resistance, and there is a external resistance connected here. Now what I want to do, I want to measure what is the potential difference across this resistor. So what I will do, I will connect a voltmeter parallel to that ideal voltmeter. So what is its resistance? Infinity. So that's why this voltmeter is not going to affect the this voltmeter is not going to affect the resistance of the circuit, and voltmeter will not have any current field. Okay, the circuit current is not going to be affected by the voltmeter. Why? Because the voltmeter has very high resistance or infinite resistance. Second thing, I want to also measure what is the current flowing in the circuit. So what I will do, I will connect an ammeter, right? How I should connect the ammeter? We should connect an ammeter in series to that one. Understood? And what will be the resistor ammeter? That's going to be 0. Understood? So if it is ideal voltmeter and ideal ammeter, they won't give you the resistance value. Why? Because if it is an ideal condition, then voltmeter resistance I have to consider infinity. And if it is an ideal ammeter, then I should consider its resistance to be how much? 0. Understood? But sometime you may get a case where the voltmeter resistance will be given to you, ammeter resistance will be given to you, or it will be said that it is a non-ideal voltmeter and ammeter. In those cases, the resistance value, some finite value will be given to you. Means a voltmeter resistance, something finite will be given, and ammeter resistance also something finite will be given in the question to us. Okay, so let's discuss first one question on आराम से बैठे हो ना. Okay, so ideal voltmeter and ideal ammeter, if it is given, then its resistance is going to be infinity and 0. But if it is non-ideal, then they will provide us the value of resistance. Okay, now. So let's take two example. First example I'm going to take here an ideal voltmeter. Okay, ideal voltmeter condition I am going to take it, and ideal ammeter condition I am going to take. Okay, let's say a circuit is given to us. This is 10 ohm resistance. This is also 10 ohm resistance. This is given 20 ohm resistance. Let's take that also 10 ohm. Okay, 20 by 3 and 20. I'm just checking some value. Understood. This is the situation given to us. Okay, this is the situation given to us. Now in this question, I want to know two things. Okay, what is the potential difference across this resistor? Okay, understood. Which resistor? This resistor. What is the potential difference? I want to know. So what I will do it? I will connect a voltmeter. है ना? Understood. So whatever is the reading of this voltmeter, that will be the potential difference. आराम से बैठो. Okay, that will be the potential difference across this 10 ohm resistor. And we also want to know what is the current in the circuit. So what I will do it, I will connect an ammeter, right? So this ammeter will give me what reading? This ammeter will give me what what is the current flowing through the battery. Okay. If they want the current in some other resistor, then what we will do, we will connect the ammeter across that resistor where we want to find out. Okay. So now please tell me what is the answer coming to us, or the question will give us like this: find reading of find reading of voltmeter and ammeter. Okay, clear? Both are ideal. Consider them as what? Consider them as ideal. Consider them as what? The ideal means voltmeter is also ideal and ammeter is also ideal. And let's find out what is going to be the reading of the voltmeter and reading of ammeter. These are the two things they are asking in the question. Please tell me how much is this coming? बैठो पापा क्लास ले रहे हैं ना बैठिए आप आराम से ठीक है आराम से बैठो so please tell me how much is this coming what is the voltmeter reading coming and what is the ammeter reading coming tell me is the voltmeter resistance is going to affect our circuit no na it's an infinite resistance so it will just measure the voltage it will not contribute anything in the current isn't it and same thing for the ammeter also okay so now if you look at that can you tell me this 20 ohm and 10 ohm how it is connected can you tell me this 20 ohm and 10 ohm how are they connected so you can say this 20 ohm and 10 ohm are connected in parallel. So 20 into 10 by 20 plus 10. So what are we getting? We are getting 20 by 3. And if you look at the other resistance like this 10 ohm, 10 ohm and another internal resistance as 10 ohm, they will find out that these three 10 ohms are connected in what? Series. So 30 ohm it will become. And whatever the resultant of these two will come, which I got it as 20 by 3, can I say this 20 by 3 is connected in series with the another 30 ohm? So the R equivalent of the circuit, how much it will become? It will become 20 by 3 plus that another 30 ohm. So this 20 by 3 and 30, how are they connected? They are connected in what? Series. So what are we getting? 3 into 30, 90 plus 20, 110 by 3 ohm we got it. So it means about these two end, what is the total resistance of the circuit? So total resistance of the circuit is 110 by 3. So what will be total current in the circuit? Can I say the total current in the circuit is going to be 110 volt is the EMF, 110 by 3 is the resistance. So 3 ampere is the current. Please tell me, understood this 3 ampere thing? That means what? Can I say in this branch, the current of 3 ampere will flow? Is the 3 ampere current is going to pass through the ammeter? So what will be my reading of ammeter now? So can I say the reading of this ammeter is going to be the 3 ampere? What is the reading of this ammeter? It's going to be 3 ampere. Now, although that has not been asked in this question, but it can come in some different set of questions. Like, if I ask you in the question, tell me what is the current in this branch and what is the current in this branch? Can you answer it? How are these two connected? 20 and 10 ohm? Tell me, how are these 20 and 10 ohm are
Parallel.
connected? Parallel, right? And in
Parallel.
parallel, potential difference remains same. So can I say this
Same.
3 ampere current is going to distribute in the two branches, and how it is going to distribute? So what is the resistance ratio? In that ratio is the current is going to distribute. Resistance ratio means 10
Yes,
into
sir.
10 into 20. So current is going to distribute in what ratio? 1 is to 2 ratio. So let's distribute 3 ampere into 1 is to 2 ratio. And this is higher resistance. So less current I will give it. So 1 ampere is the current in upper branch. And this matlab 20 ohm will have what current? 1 ampere current. 10 ohm will have what current? So 3 divided by 1 plus 2 into 2, 2 ampere. Understood the current in these two branches? Now again when it reaches this junction, how much current it will become? The same current 3 ampere. What is the current flowing in this branch? 3 ampere. What is the current flowing in this branch? 3 ampere. Now tell me, ammeter reading how much we got it? 3 ampere. Voltmeter reading. Voltmeter reading means what? The voltage across this blue color resistor, 10 ohm resistor. So can you tell me, am I asking you this thing? If I call this point as x and if I call this point as y, am I asking you in the question what is Vx minus Vy? Isn't it? That is the potential difference between the point x and y. And that we will get it as the reading of the voltmeter. So how much is the current? 3 ampere, resistance 10 ohm, 30 volt we got our answer. Understood? So what will be voltmeter reading? So can I say the voltmeter reading is how much? The voltmeter reading is 30 volt. Ammeter reading is what? Ammeter reading is what? 3 ampere. Understood? But both the things which is given in the question to us is the ideal one. Okay, so that's why you will be thinking, sir, 3 ampere current came here, right? There is some doubt like this. Sir, 3 ampere current came here, right? So isn't it this x junction? It should distribute in 10 ohm and voltmeter. Yes, it should, right? But think about the resistance of the voltmeter. Isn't it very high? Very high means what? Compared to 10 ohm resistor, the voltmeter is going to have negligible current, because again I have to distribute it into what ratio? 10 is to infinity ratio. Current is distributed in what ratio? Uh, in the ratio of their resistance. So that's why here we are not considering any current in the ammeter. Understood? The simple reason is what? That the reason is that it is a very high resistance, or another way you can say that it's a kind of infinite resistance. Okay, so if an infinite resistance is given to us, what will happen? There will be uh, zero current or negligibly small current. Okay, let's take another example where I'm going to give you a non-ideal voltmeter. Okay, let's take one example here. This is 100 ohm. Okay, this is given as 200 ohm. There is a battery current here. Battery internal resistance not given. Again, sometimes the battery internal resistance they will not give you. Then it is called ideal battery, ideal cell. And if the battery resistance is given, non-ideal or real one. Okay. There is a voltmeter also given to us. We want to measure the potential difference across 200 volt. So I connected a voltmeter here. It's a non-ideal one, and its resistance is also given to us as the 200 ohm in the question. Okay, and this battery EMF is how much given to us? battery EMF 50 volt. There is no resistance of the internal resistance of the battery. Okay. Again, they are asking in the question same thing. Find reading of what? Reading of the volt meter. But it's not an ideal one. Okay, na? So find the reading of this non-ideal voltmeter and tell me how much is this coming to us. Please tell me what is the answer coming.
$50, sir.
How much is that coming? 50 volt. 50 volt, so that's complete battery voltage, right?
1 minute, sir.
It can't be 50 volt, isn't it? Because the entire battery voltage is 50 volt. So some voltage will come across 100 ohm resistance, some voltage will come across 200 ohm resistance, isn't it? It can't be exactly all will fall here, na?
Yes, sir. 1 minute, sir.
Yeah, please check it. Everyone trying or not? Please tell me. Minal, Sharan, Lokesh, you also.
Yes.
How much it will come? See that this 200 volt, this voltmeter resistance is given now. It's a similar to just a resistor. Okay, it's not going to make any different thing here. Okay, so this voltmeter has 200 ohm. This is 200 ohm. Can I say these two are connected in parallel? 200, 200 in parallel. What I will get it? Am I going to get it 100? Tell me. 200 ohm, 200 ohm in parallel connection. Is that going to give me the 100 volt? So that these two are going to give me how much? 100 volt. And that 100 ohm, 200 ohm, 200 ohm in parallel. है ना? You can write it R1, R2 by R1 plus R2. है ना? So you will get it 200 again. Sorry, 100 we will get it. है ना? Now that 100, is it connected that 100 with another 100 in series? So actually R equivalent of the circuit is what? 100 plus another 100, which means 200 ohm. So that means what will be current in the circuit? V by R. So 1 by 4 ampere or 0.25 ampere, you can say that, right? So that means if I ask you what is the current in this branch flowing, can I say that 0.25 ampere? 0.25 ampere. 0.25 ampere up to this. Current will reach here. Now tell me, is this current is going to distribute? But you will say, sir, earlier you did not distribute. Yes, earlier I did not distribute in the voltmeter. Why? Because earlier the voltmeter was ideal. So it was having infinite resistance. Ammeter was ideal. So it was having zero resistance in the last question. So that's why I did not give any current to the voltmeter. Right, but here they are having a comparable resistance, the voltmeter and 200 ohm. So here the current will distribute. Okay, so if you distribute the current, both are same resistance, parallel connection, 1:1 ratio the current will distribute, or another way you can say that half current will distribute, means this is going to have how much current? 0.125, and this is also going to have how much current? 0.125. Now let me mark this point as something x, and this is y. So what is the Vx minus Vy now coming to us? Is that coming 0.125 into the resistance 200? So what are we getting? 25 volt. Please check it once. So what is the reading of voltmeter now? So reading of the voltmeter will come. It will come just 25 volt. Understood? Please tell me. Okay. Please tell me. Clear this one?
Yes, sir.
Right. So this is what we had. Okay, now. So voltmeter, if it is given ideal, we will consider its infinite resistance, and real case, it will be given some resistance to us. Okay, now. Right. So next thing we have to discuss is about what is the power consumption in the resistance, heat consumption in the resistance. Okay, now heat developed. So these things we will continue it tomorrow. Okay, tell me. Okay, so let's meet it tomorrow. Okay, and then we will continue. Right. Good night, everyone. Take care.